So now that we have our algorithm, let's program it. So we'll start with step 1, which was gather input from the user. Now if we write our algorithm in pieces, and we test each piece before it's put together in the whole program, then we should always have a working program. And at the end, of course, it will be working. So let me think here. Scanner keyboard equals new scanner, calling the constructor for our scanner class, with system.in as the argument. And now we can use that keyboard object to gather our input from the user. Now we should give some kind of direction to our user, so let's print out a line that will ask the user to please enter the weight of the sphere and gather that weight from our user. Now we have to think what type of variable would we like our weight to be, and since weights can sometimes have decimal points, let's make our weight a double. So we'll use that keyboard object to gather our input. So keyboard dot next double, there he is. Calling the next double method of the scanner class. And just to see that we've entered in the weight properly, we'll have another output line here and say the weight you entered is, and then we'll print out our weight variable. And in this way we can make sure that our steps are going to work. So now we have step 1 written. I want you to test it, make sure it runs. Yes, it's an easy step. It's always good to test as you go. Okay, in our output it says please enter the weight of the sphere. We can put 34.4. And the weight you entered is 34.4. So everything looks like it's running well. Let's move on to step 2 then. Or actually, step 1.5. Step 1.5 says to figure out our volume. So we'll come down here in our code. Let me scroll the screen down here, and let's code step 1.5. So we'll say double volume. It will make him a double as well because he could have a decimal value. Then we'll say 4 divided by 3.0. We want it to be 4/3 with a decimal point, so we don't want to have an integer divided by an integer, so we'll make one of them a double. Times pi times the radius times the radius times the radius. So let's program for get our radius from our user. Please enter the radius of the sphere. And we'll make this our radius. And we'll make sure that our radius is inputted correctly. And we're to double click Control C, double click Control C or Control V to copy and paste those variables. And the only thing it doesn't like is our pi. We'd like pi to be a constant. So we'll put him up here on top of main. We'll call him a static, and we'll make sure that he's final. That makes him a constant. And this should say static. And we'll name him pi. And we'll take him out to 6 significant digits there. We need to also give him a type, double. There we go. Now everything looks like it's working. To make sure that it's working, let's output our volume and test it before we move on to the next step. So double click Control C, double click Control V, double click Control V. Let's test our code. Asking us to save. says please enter the weight of the sphere. The weight you entered is 34.4, the radius of the sphere, and it gives us the volume. So step 2 was to calculate the buoyant force. So we'll come down here in our code, paste our step. Our step is pseudocode-like, so we don't even have to retype this. We'll select it and paste it. Of course, it needs to know what type of variables those are. Double-click Control-C and make him a double as well. And the specific weight of water was given to us in the programming problem, and it was 62.4. And of course our semicolon. Alright, to make sure that our buoyant force is calculating correctly, let's go ahead and print him out. Alright, so now let's test our step 2. Now, of course, we should test it with the numbers that we've already tested on our desktop. So we could test these numbers with a regular calculator outside of our program to make sure our program is indeed working the way it's supposed to. Alright, so if our weight was 34.4 and our radius is 3.4, the volume is 164, and the buoyant force is 10,273. Now that's not the end of our program. Yes, we've gotten some output and we've figured out the buoyant force, but remember that we need to perform step 3 here, and the real output we wanted was whether the sphere is going to float or sink. So let's program our branching statement, our step 3. So we can write something exactly like our pseudocode that we wrote into our step. We wrote if the buoyant force is greater or equal to the weight, then we're going to output that the sphere will float. So our output will be it will float. Otherwise, we would like to output it will sink. Alright, that's our step 3 and our step 4. So I kind of jumped the gun and wrote step 4 there, but that's okay. They kind of went together since they were a branching statement. Let's go ahead and test it now again. Notice that we're testing as we go. Every time we test our program, every time we add some lines of code, we test our program. That way we always have a working program. And at the end, it will work as well, and our sphere will float. So that's how you take an algorithm. You program each step, test each step as you program it, and at the end, you should have a great working program.